Hi everyone and welcome back to Mass Material channel. In this video, we are going to talk about monotonically increasing and decreasing sequence. So let's explain what does it mean for a sequence to be monotonic. A monotonic sequence is either increasing or decreasing. For example, for the increasing sequence, each term is greater than the previous one. Here we can see that a sub 2 is greater than a sub 1 and a sub 3, which is the third term, is greater than the second term. So a graphical representation of these kind of increasing sequence would be something like this. As we see here, each term as n goes up is greater than the previous one. So for these kind of sequences, a sub n plus 1 is also greater than the previous term, which is a sub n. To clarify the difference between strictly increasing and increasing, I should say that strictly increasing means each value is greater than the one before, with no repetition, while increasing just means the values are getting larger overall, but they can stay the same. Here we can see that, for example, a sub 4 is greater than or equal to a sub 3 and a sub 5 is greater than or equal to a sub 4. So overall it's going up, but some terms are greater than or equal to other one. Now let's define a strictly decreasing sequence, which is a sequence where each number is smaller than the one before it. So basically it's like going down a staircase where each step is lower than the previous one without any steps being at the same height. Similarly, if we use the greater than or equal sign instead of just greater than sign, we can represent the decreasing sequence like this. So to sum up, we say that a sequence is monotonic if it is either increasing or decreasing. There are various methods to determine whether a sequence is increasing or decreasing. Here are a few common approaches. The first one that we could mention is visual inspection. In this method, we can simply just look at the terms of the sequence and observe if they are getting larger or smaller as we move along the sequence. Consider the a sub n is equal to n squared as an example. Let's start listing out a few terms to get a feel for what's going on. The first term simply 1. The second term would be 4. And the third term would be 3 to the power of 2, which is 9. If we plot this sequence in a Cartesian plane, we would expect something like this. So we can see that the sequence is monotonically increasing as n gets bigger and bigger. Now let's consider the sequence a sub n is equal to 1 over n as an example for monotonically decreasing sequence. So let's list out some few terms. The first term is 1. The second term is 1 over 2. The third term is 1 divided by 3. So we can see that as n increases, the term of the sequence decrease. So if we plot the sequence on a plane, we can see that as n grows, the terms of the sequence is gradually approaching to the zero. Another approach to determining whether a sequence is monotonically increasing or decreasing is by just simply calculating the difference between two consecutive terms. We know that for monotonically increasing a sequence, always the a sub n plus 1 terms is greater than or equal to a sub n. If we rewrite this mathematical notation by subtracting the both sides by a sub n, we can rewrite the expression like this: a sub n plus 1 minus a sub n is always greater than or equal to 0. Similarly, for a monotonically decreasing sequence, the same rule applies, but the only difference is that we must change the inequality signs from greater than or equal to less than or equal. So we have this notation for monotonically decreasing sequence, which a sub n plus 1 is always less than or equal to a sub n. And we can rewrite the expression like this: a sub n plus 1 minus a sub n is less than or equal to 0. Now let's take the sequence a sub n is equal to 3n minus 1 as an example and determine whether it's monotonically increasing or decreasing. To do this, we will calculate the a sub n plus 1 minus a sub n. If this expression is greater than or equal to 0, we have an increasing sequence. On the other hand, if it is less than or equal to 0, we have a decreasing sequence. So let's compute the terms. We have that a sub n is equal to 3n minus 1. In order to calculate the term a sub n plus 1, we just simply substitute the n with n plus 1. So we have 3 times n plus 1 minus 1. If we distribute the 3 from the left side, we have 3n plus 3 minus 1. After simplification, we have 3n plus 2. Now let's calculate the difference between these two terms, which means that a sub n plus 1 minus a sub n is equal to 3n plus 2 minus 3n minus 1, which is after simplification is equal to 3, and 3 is greater than or equal to 0, so we have an increasing sequence. As another example, let's consider the sequence a sub n equal to 5 minus 2n. If we calculate the a sub n plus term, we have 5 minus 2 times n plus 1, which is equal to 5 minus 2n minus 2. If we subtract the a sub n from a sub n plus 1, we have 3 minus 2n, which is this part, minus 5 minus 2n. After simplification, we have minus 1, which is less than or equal to 0, so we have a monotonically decreasing sequence. Our third rule for finding out whether a sequence is increasing or decreasing is calculating the ratios. We found that for any increasing sequence, a sub n plus 1 is greater than or equal to a sub n. If we divide both sides of an equality by a positive variable, there is no need to change the direction of the inequality signs. So this rule is useful for a sequence that are not negative. So by dividing the both side with a sub n, we have a sub n plus 1 divided by a sub n greater than or equal to 1. In a similar way, we have for decreasing sequence a sub n plus 1 is less than or equal a sub n. If a sub n greater than 0, we can divide the both sides without changing the sign. So we have a sub n plus 1 divided by a sub n is less than or equal to 1 for a monotonically decreasing sequence. Okay, now let's consider this example, which the nth term of the sequence is 3 times 2 to n minus 1. By calculating the ratio of a consecutive terms, we can write that 3 times 2 to the n plus 1 minus 1 over 3 times 2 to the n minus 1. After simplification, we have 2 to n over 2 to n minus 1, which is equal to 2. And since the ratio of a consecutive terms is always greater than 1, this sequence is monotonically increasing. In a similar way, we can also show that the sequence a sub n equal to 2 over 3 to the power of n is a monotonically decreasing sequence. So let's calculate the a sub n plus 1 over a sub n. The numerator would be 2 over 3 to the n plus 1, and the denominator is gonna be 2 over 3 to n. By using the product rule for exponent, we can rewrite the numerator to 2 over 3 to the power of n times 2 over 3, and the denominator is simply 2 over 3 to the n. These two terms cancel out each other, and the fraction is equal to 2 divided by 3, which is less than 1. So since the quotient is less than 1, we can say that this sequence is monotonically decreasing. Our fourth rule for determining whether a sequence is increasing or decreasing is just by use the derivatives. We know that if the sequence is represented by a continuous function, we can use the calculus to find the derivative. So in order to take the derivative for a sequence, we should simply replace the n, which is a representative of a natural number, with the symbol x for a real number. Then we can calculate the derivative for the function, and we know that from the calculus that if the first derivative for a function is a positive number, that function is increasing. And if the first derivative is less than 0, the function is decreasing. Okay, so let's go ahead and take the derivative of a function in an example. Let's consider the example a sub n is equal to e to the n. By defining the continuous function for this sequence, we can write that the f of x is equal to e to the power of x, which is a continuous function. And by taking the derivative for this function, we know that the first derivative for this function is equal to also e to the power of x, which is always a positive number. So the function is always increasing. By knowing this, we can conclude that the related sequence a sub n is equal to e to the power of n is always an increasing sequence. Now let's define another example and take the derivative from the continuous function to show its monotonically decreasing sequence. Consider the sequence a sub n is equal to 1 over n. The continuous function form for this sequence is that f of x is equal to 1 over x, which can I write it to the form of x to -1. If I take the derivative from this function, I have -1 over x squared. I know that x squared is always a positive number, and then if I have a -1 in the numerator, then for sure that this derivative is always less than 0. So the function is decreasing. So what does that tell me? That tells me that f of x is decreasing on all real numbers. And since I've shown that f of x is decreasing on all real numbers, this means f of n is going to be greater than f of n plus 1. And basically, that allows me to now say that the sequence is a decreasing sequence, because a sub n is always greater than a sub n plus 1.